Okay, Assalamualaikum everyone. Okay, in the previous lesson, we talk about the multiple linear regression and then the way how to estimate the parameter and estimate the regression equation ataupun regression function when involving the several independent variables. Okay, dipanggil multiple linear regression analysis. Okay, so today we proceed with the analysis of the variance result untuk multiple linear regression. Okay, so basically it is exactly the same as you find the ANOVA table when we deal with a simple linear regression. Okay, which is we use the method of the approach of matrix. Okay, so in order to create the ANOVA table, we need the SST, SSE dan juga SSR, and together with that you need to determine the degree of freedom for each of these sources of variation. And then our intention actually adalah untuk dapatkan value of F, right? F statistic, which is from that we can test for the significance of our model. So now we talk about the multiple linear regression function lah. Kita nak check whether our model, okay, our regression model is appropriate or not, ataupun is significant or not before we can proceed with the other method, with the other procedure, okay, the other task, t-task, Bonferroni, and so on. Alright, so if you can remember, to find the SST using the matrix approach, it is y transpose y minus dengan 1 over n multiply dengan matrix of y transpose multiply j multiply matrix of y. You know the matrix of y, how to transform daripada data, raw data kepada matrix of y. And then you also know that y transpose y adalah summation of yi square, kan? You have learned before this. Okay, this part adalah summation of yi square juga, kan? So n here, which is the number of observation ataupun number of sample size. Okay, y transpose j adalah matrix j adalah matrix, the square matrix that the entry is all entry is 1, right? Okay, and then y adalah matrix y lah. Okay, so kat sini juga SST juga you know that it is summation of yi square minus dengan summation of yi, okay, all of that square divide by small n, kan? Okay, here summation of yi square means that you need to square the y first, baru you sum up this part, sum up the y, baru you square. Okay, SSE also notation to SSE biasanya adalah matrix of residual transpose multiply the residual, and then it is actually adalah summation of EI square, right? You squarekan the residual, each residual from the observation. Okay, you sum up of that, you akan dapat SSE actually. Okay, we also usually use this matrix, this formula for matrix approach to find the SSE, which is y transpose y minus dengan B transpose. B transpose adalah matrix of beta naught, the estimator of the parameter. Okay, let's say kalau kat sini kita ada dua independent variable. So kita punya beta will be matrix of B will be 3 by 1. So B transpose will be 1 by 3. Okay, X transpose Y. Okay, you already know the entry in the matrix of Y transpose X transpose Y. Okay, SSR pula adalah B transpose multiply X transpose Y and okay, ni matrix. Let's say kita kata kita ada dua Y lah kan. Sorry, kita ada dua X. Okay, so B transpose will be 1 by 3 and the matrix of X transpose Y will be 3 by 3. Sorry, X transpose Y, matrix X transpose Y adalah X transpose X baru 3 by 3 kan. X transpose Y will be the 3 by 1, right? Okay, 3 by 1, which is summation of Y, summation of x1y, and summation of x2y. So it's 3 by 1. So you akan dapat satu value lah bila you multiply these two matrix. K minus dengan this part. K this part adalah ni lah, kan? Sama dengan yang ni. Okay, which is summation of yi square divided by n. Okay, and then you know that the degree of freedom for SSR adalah P minus 1 and the degree of freedom for MSE adalah N minus P. Before this, kalau in simple linear regression, your degree of freedom untuk SSR is 1 biasanya kan. Di sini will be N minus 2. Okay, sebab apa? Because of you deal dengan hanya satu independent variable. So parameter, kalau simple linear regression, parameter dia beta 0 and beta 1. So sebab itulah 1 kat sini, 2 minus 1. Okay, dekat sini n minus 2 sebab parameternya 2 kalau simple linear regression. But kalau in multiple linear regression, your P here depends pada your how many independent variable that attach in your data. Kalau ada x2, so here will be 3 minus 2. So kat sini will be 2. Kat sini will be n minus 3 sebab parameternya 3. Kan kalau you punya x ada 3, so parameternya will be 4, beta 0, beta 1, beta 2 and beta 3. Okay, so it depends pada how many variable involved, okay, in your data set. Okay, so you need to know the degree of freedom for each of these sources of variation. Okay, and then from that you can find the mean square of the regression dan juga mean square error, which is the sources of the variation tadi divide dengan its degree of freedom. And then lastly, you akan dapat value of S statistic, which is MSR divide dengan MSE. Right? Okay, so dalam your textbook ada example of this actually. Page 243. Okay, page 243. Okay, dalam your textbook. Ya, betul lah. Page 243. Okay. Alright. So actually, data yang ni continuous from the previous example sebelum ni. Kalau you tengok dekat page 237, we have the data of about sales dan juga number of person age 16 or younger dan juga income. Okay, so X1 you adalah number of person age 16 and X2 adalah personal income. So dia tengok kat sini sales in community. Okay, the sales. Okay, dia punya Y adalah sales. So, kita ada how many data altogether kat sini. You akan ada 22 data. 20. Sorry, 21. Ada 21 observation. Okay. So, from there, okay, you can create the Y transpose Y, which is, actually adalah the value of summation of yi square. Okay, and this part adalah summation of y square divide dengan small n. Alright, we need these two value nak cari SST. So we have the value of SST here. Okay, untuk dapatkan SSE, you apply the formula y transpose y minus B transpose multiply X transpose Y. So, yang ni lah kan, yang saya tunjuk tadi, which is summation of YI square. Minus dengan here adalah value of beta naught, beta 1, beta 2, which is that you have learned before this in the previous lesson. Using the matrix approach to estimate the value of beta, and also from there you create the multiple linear regression function. Okay, so kat sini will be 1 by 3 like I said just now. And then here adalah 3 by 1 matrix, which is matrix of X transpose Y, which is here, the entry here actually adalah summation of YI, right? Summation of XIY, sorry, XI1, right? Di sini summation of XI2 YI. Okay, so when you apply the formula, you minus these two, you will get this answer. So SSR, simply you can, if you have these two value, SST dan SSE, so SSR just SST minus dengan SSE. But if you want to use the formula yang tadi untuk dapatkan SSR, right, this formula pun boleh, tak ada masalah. So you akan dapat the same answer. Alright, so you can, since you have all this value, you can create the ANOVA table. So kalau kat sini you punya degree of freedom, so kalau you create the ANOVA table, you will have the sources of variation. So it will be regression. So here will be as degree of freedom dan juga MS, right? So you will have the error and total. So you will have here SSR, you put the value of SSR here, you put the value of SSE here, dan juga SST. The degree of freedom for the regression is P minus 1 tadi kan. So now we know that our P adalah ada berapa parameter here. It is 3 parameter here. So here will be 2, which is P minus 1. The degree of freedom for error is N minus P, which is 21, minus dengan 3, you will get 28. And then the SST N minus 1 adalah kenapa? It is 18 lah. Right, 21 minus 3. 18. And then here is N minus 1 will be 19. So MS here adalah MSR dan juga MSE, which is the SSR divide dengan 2, you akan dapat MSR. SSE divide dengan 18, you akan dapat MSE. Okay, so that is your ANOVA table. Okay, and then we can use this ANOVA table to find the F statistic, which is we need that value to test for the significance of our model. So kita punya model sekarang ni adalah this our model. Sebab I buat ni because of contoh tadilah, which is we have, let's say we have two independent variable. Okay, so we have this model, two independent variable and three parameter here. So kita nak check whether this model is significant or not. Okay, so kita akan test dia punya macam biasa nak buat test, nak to conduct the test, we need the hypothesis testing, we need the test statistic, and we need the decision rule. Okay, dan juga critical value. Okay, so untuk simple linear regression before this, you nak check untuk significance of the model, you akan gunakan beta 1 saja kan, sebab you hanya ada satu independent variable. So you test untuk beta 1 saja, kita test untuk slope. Sama juga dengan multiple linear regression. Okay, you akan test untuk all the slope kat sini, beta 1 dan beta 2 if we have two independent variable. Okay, if you have 4, so here will be beta 1, beta 2, beta 2, beta 3 and beta 4 equal to 0. And H1 nya adalah not all the beta equal to 0. Okay, kena tulis betul-betul lah. The test statistic will be from the ANOVA table tadi, which is MSR divide dengan MSE, and then you need to compare the test statistic with the critical value from the F table. Okay, from the F table. Okay, so we reject H0 if the F statistic is more than the value from F table. Okay. Okay, kalau guna tabel merah, so it will be F alpha. Okay, so kat sini dia buat 1 minus alpha sebab dia gunakan tabel yang belakang tu adalah tabel less than. Tapi you kalau you refer your statistical table yang merah tu, it is more than table. Okay, so kat sini, okay, remember, hati-hati dekat sini, you kena ambil degree of freedom untuk SSR dan juga SSE. Sebab tu here will be P minus 1 dan juga N minus P. Kalau kita tukar degree of freedom for these two, the value for the critical value here will be different. Okay. Alright. So if we reject H0, kalau kita reject H0 maksudnya kita tak terima this decision. Kita tak terima this decision kalau kita reject H0, means that not all the beta equal to 0. So kalau kita reject H0 means that we have the significant result. So we can say that the regression model is significant. This model yang kita create ni is significant. So at least one of the beta will be at least one of the independent variable is significant. So lepas ni kita akan check untuk t-test and so on. So first of all kena check dulu f-test sebab kita nak tahu whether our model is significant or not. If our model is not significant, no need for us to test untuk each of the independent variable. Okay, so because of that you kena test untuk f dulu. Kalau f significant, kalau f-test is significant, it means that our model is significant or appropriate. So baru kita boleh proceed dengan kita test untuk setiap each of individual, okay, independent variable, which independent variable are significant to the model. Okay, so if we reach a H0, we can say that the model is significant, or we can say that at least one of the independent variable are significant. Okay. Let's see the example here from the previous example juga. Okay. So because of here we have two independent variables, so H0 nya will be beta 1 and beta 2 equal to 0, ataupun boleh juga tulis macam ni lah, macam biasa kita tulis. beta 1 equal to beta 2 equal to 0. So here not all the beta 1 and beta 2 equal to 0. F adalah MSE divide dengan MSR divide dengan MSE. So you dapat 99.3 and we need to compare it with the critical value from F table. So here 3.55. You cuba check gunakan table merah yang you ada. F 0.05. 2 and 18, you will get the same answer, 3.55. Since this F statistic more than the critical value 3.55, we conclude hash not, which is we conclude hash A, which is we reject hash not. So means that the sales are related to the target population and the per capita income. Okay, sales Y are related to X1 dan juga X2. Or we can say that the model that we create tadi is significant, okay, or at least one of these independent variable is significant. Okay, we proceed a little bit with the coefficient of the multiple determination. Sama juga sebenarnya macam sebelum ni. The formula is this. Ada dua, sama ada digunakan SSR dan SST ataupun SSE dan juga SST. Okay, it measures the proportionate reduction of the total variation in Y associated with the use of the set of the X variables. Okay, kita nak tengok ada reduction in the total variation in Y when variable X1, X2, X3 and so on is used in our model. The coefficient of the multiple determination reduces to the coefficient of the simple determination in the simple linear regression. When one of X is in the regression model. So, macam sebelum ni juga, the R square ni will be lies between this value. Okay, the value of R square is always positive. Di antara 0 to 1 sahaja. So, bila you nak interpret R square, you kena multiply dengan 100. Okay, kita baca sikit kat sini. Adding more X variables to the regression model can only increase the R square and never reduce it because SSE can never become larger with more X variable. Okay, and SST is always the same for a given set of the responses. Okay, bila SST will be sama je. Kalau you try buat, bila you masukkan beberapa X in your model, gunakan data yang sama, SST will be equal, tetapi SSE will be never become larger. Will be sama ataupun lower. Okay, so because of that, dikatakan bila add more variable, bila X bertambah, R square will be increased. Okay, R square will be increased. Sebab SSE kat sini akan rendah. Semakin rendah ataupun sama. So, bila dia rendah ataupun sama, so 1 minus the value kat sini, it will be increase the R square lah. Okay. Since R square usually can be made larger by including a larger number of predictor X. Okay, so R square akan increase when X when we include the other X dalam kita punya data set. It is sometimes suggested that a modified measure be used that adjusts for the number of X variable in the model. So the adjusted coefficient of the multiple determination dipanggil R square A, dipanggil ataupun notationnya R square A dipanggil adjust R square by dividing each sum of square with its associated degree of freedom. So the formula is SSE tadi kita bahagi dengan its degree of freedom dan SST kita bahagikan dengan its degree of freedom. So this is the formula. This adjusted coefficient of the multiple determination may actually become smaller when another x variable is introduced into the model, because any decrease in SSE may be more than offset by the loss of the degree of freedom. So kalau R square tadi, R square dia akan sentiasa increase when we add the other independent variable in our dataset. Tapi R square adjusted can be smaller than uh, the value of R square when we adding the other independent variable, sebab dia ada ni minus dengan divided dengan its degree of freedom. Okay, so sebenarnya untuk MLR R square adjusted ni hanya ada untuk MLR sahaja, and then it is more reliable actually kita gunakan R square adjusted than R square value. Tapi for practical kita boleh jugalah kita it is also relevant if we use the value of R square untuk nak interpret the total of variation in the dataset. Okay, and then from that we'll also can find the value of R. Bila ada R square, bolehlah cari value of R, which is square root of the R square. Okay, this is the example to find the R square from the previous example. So here we get 0.917 R square. Kalau nak interpret, you boleh multiply dengan 100. So, kita boleh tengok the value is 91.7%. So, bila ada dua variable in our model, dia punya total of variation is 91.7%. So, tinggilah. So, yang kita nak adalah the higher of value of R square is better. Okay, the higher the value of R square is better, means that the variable yang ada dalam kita punya model tadi tu is valid. Okay, tapi kita kena ada lagi lah another evaluation yang kita perlu buat nanti. Thus, boleh kata kat sini, when the two predictor variable, which is the target population, and the per capita disposable income, which is X1 and X2, are considered in the model, the variation in sales, which is Y, is reduced by 91.7%. So we can say that when the two independent variable is included in the model, the total variation is 91.7%. Also, the value of R square will be 0.907, which is label in the output. So, kalau nanti kita tengok output SAS dan juga output SPSS, you akan dapat value yang sama lah. Alright, so that's it.